All right, welcome everybody to week 3, day 1 of IS50A game development. Today is the first day in which we are going to do coding inside of Unreal Engine. So today we are going to learn how to make programs essentially run within your game. Everything we've done up till now could be considered like art, right? This is a game development class, not necessarily a game programming class, game development class. But today you're going to actually learn how to start programming video games, and you'll see it's actually pretty... maybe not as scary as you thought it would be. A lot of times when you see people coding, you see them in these like text editors that look like they're hacking the NSA. We're going to be coding using something called blueprints, which is a visual way of doing programming. So the first thing I'm going to do is just create a zone that when I walk into it, it's going to play a sound. So there's a lot of different ways you can get your code to start running. The most common would be like touching something, walking into something. For example, if you've ever played a video game with doors, a lot of times you just walk up in front of a door. You don't even touch it. You just kind of walk into the area in front of it, and then the door slides open. There's probably an invisible zone there that is triggering. And so let me show you how to do that. So if you go to selection mode, I was in foliage mode. If you go into selection mode, and you see there's this thing called a trigger box. So trigger box is something that is designed, it's invisible. Like while you can see it in the editor here, you will not see it if you hit play. So I'm just going to put the little trigger zone right here. And you can see if I hit play, foliage is causing a nice little delay. Maybe I will delete it. If I come over here, you'll see you can't see it inside of the world. And if I walk over it, absolutely nothing happens. Why? Because I haven't written any code yet. So I've got this box out here in the world, and I'm going to come over here and turn it into a blueprint. So right there is, in earlier versions of Unreal Engine, it was a giant blue button. In Unreal Engine 5, it looks like a little flow chart. Okay, so you're going to click on that thing there. And you're going to give it a name. I'm going to call this one audio box BP, maybe something like that. Underscore BP. And I'm going to save it in my build directory. You can save it in whatever directory has your name on it. And I'm just going to hit select like that. And then I'm going to go over to my build directory. And you can see here it is, audio box BP. And I'm going to hit Control-Shift-S and save it. Just always get into the habit of saving all, because Unreal Engine crashes not rarely. Okay. So here we have, when you open up your blueprint, and if you ever close out of it or something, you can come back in to edit your blueprint by just double clicking it like this. And you will see in the viewport screen here what the blueprint looks like. In this case, there's absolutely nothing that'll be visible inside of the world. Whenever you see something like this with an icon, the icon's there to make it easy to click on. It's kind of hard to click on those edges there. You can. This is an invisible thing, and it does nothing by default. So let's make it do something. So here on the event graph is where the magic happens. Okay, this event graph you're going to become very, very familiar with over the years. Okay, because hopefully you're going to be doing this for years. Game development is not something you can learn all in one semester. It takes a lot of time and a lot of practice to get good. And the 50B people have already finished A, and I'm pushing them even further now. So here inside of Event Graph, you can see 3 common places that are like entry points into the code. Okay. Begin play runs once. It runs when the game begins. And so, for example, I can have this thing play a sound. Play sound 2D. Play sound 2D means it just comes out of my speakers. So there's no attenuation. It's not like in the world somewhere. When you play a sound in the world, the further it is away, the softer it is, right? And the closer it is, the louder it is. Play sound 2D is just going to play it out of your speakers with no attenuation at all. And so we'll just play, I don't know, explosion. Okay. So I'm going to select that. And now we've got a program. Hit compile. You'll see that turns yellow anytime you make a change. Anytime you make a change, you'll see that it turns yellow. Compile it, save it, get rid of the little asterisk there, and now when we go into the world and hit play, again, there's a delay due to foliage. You can see right when the game begins, we got that explosion sound. Okay. Should I delete all that foliage? It's so pretty though. Okay, so coming back into here. So begin play triggers once. Okay, and what we have here, this looks a lot like the material graph editor for our materials. What we have here though is a program. This is actually a program. And the program starts with this. The red things are the entry points. And so each one of the red boxes triggers at a different time and place. Okay, so begin play triggers when you hit play. When you hit play, it runs, it plays that explosion sound. The white line here is what shows the flow of control. So when I hit play, it follows this white line here. It plays the sound, and then there's nothing coming out of it, so it stops. If I wanted, I could attach more things to this. For example, I could have it spawn an emitter. An emitter is a particle effect. So I can spawn an emitter at my location. And how do I get my location? Well, I can type get location. And I'll get actual location like that. And I can drag this pin here. So whenever we're doing coding in blueprints, we're just basically connecting one wire to another. We're just connecting one, and they have to be the same color. Like this is orange. Orange is used for XYZ coordinates and some other things. Basically, you can think of it as a location. It's not, but if I tried putting like a location into like which particle do I want to play, it doesn't work. You see that? It says a vector is not compatible with particle system object reference. It is nice. You cannot connect it to the white pin. Only orange things can be connected to orange things. And if I do that, then when I spawn the explosion here, the explosion will be spawned at my location. So when the world begins playing, I follow the white line, plays the sound, follow the white line, it spawns an emitter. Which emitter? I picked explosion. So we'll draw an explosion at what location? My location. What scale? Scale 111 means normal scale. Rotation 000 means don't rotate it. And then it destroys itself when it's done. The other things don't matter. What do we do afterwards? Let's print a string. We don't have to do all these things. I'm just kind of showing you that when you do blueprint coding, the flow of control, it does this first, then it does this, then it does this. So it's going to print boom to the screen. Okay. Compile, save, play. Wait for 3 seconds for the foliage to go, and then we get a boom up here. We heard the sound. I didn't see the particle effect. Let's try that again. Yeah, you see the kind of missed it, but there's a little bit of smoke up there that you can see a little bit. So, anytime you want something to happen when the world begins, that's your guy right here. Okay, I don't want that, so I'm just going to disconnect it. How do you disconnect something? If you hold down Alt and click, it erases it. If you hold down Control and click, it will allow you to insert something in between. So you could do like that and do like a print, string in between there, and kind of hook that up. One thing you'll notice about blueprint coding is that the wires don't go straight very often. That one did, so good on you. But like here, like if you zoom in on that, you'll see that the line's not quite straight. And this is something that bugs me. Somebody's generating it right now. Let's put streamer mode back on. Okay. So you see that's very slightly crooked. One thing that you'll see me do a lot is I'll hit Q and Q straight into the connections so that you have a nice straight line between them all. You will hear me complaining about spaghetti code in Unreal Engine. When these blueprints get big enough, they start resembling these giant networks of spaghetti. So there's different techniques that I'll show you in the future on how to control the spaghetti. There's different ways of doing things like functions and macros and sequences. And loops and things like that that will allow you to keep the ugliness under control. For something this big, I'm not going to worry about it. So that's begin play. Okay. And if you want to delete something, like I don't want to play hello anymore, I can just tap the delete key. But now it's not going to do anything, right? So I have to rehook this up. And I can move this over here, and you can see, once again, the connector is not quite straight. So I select the two and hit Q. Now everything is right in the universe. If you want to select a lot of things, just like if I do something here, it's going to get in the way. So I'm just going to like kind of move them up out of the way. Now, one really nice tool for organizing the spaghetti is while you've got a block of code like this selected, you can hit C. C is for comment. If I hit C, boop. If I hit C, there we go. I didn't have the screen selected. If I hit C, then it will put a comment block around all of the code. And I can do something like this, like say, when the game begins, make an explosion and print boom to the screen. Okay. Now, what's cool about this comment block is, A, it tells you what's going on, right? Like it tells me, why am I doing this? What's the purpose? What's all this spaghetti doing? But there's another cool thing about it, which is you can just click and drag on the whole box and everything comes along for the ride. So instead of having to like select individual things and like pull individual things around, no need. If I want to move this whole thing, I can just drag the whole thing. And then it's like if I've got like a guy over here that I'm going to be coding on, and this guy's in the way, I can just like kind of move him like this. Okay. And I'm going to click here, and over on the details panel on the right hand side, I'll make this a little bigger. You can change the color of the comments and things like that. Make them a little fancy looking, you know. Okay. So the next entry point into your code could be actor begin overlap. This is the one that we typically associate with a trigger box. Remember, a trigger box is this invisible zone, right? That we typically use for like doors and things like that. So when you walk up to a door, you overlap the box, and then it sends a message to the door saying, hey, swing open, or something like that. Very rarely in games these days do you actually like take your hand and reach to the doorknob and turn the doorknob and like push on it. Like I think Last of Us did something like that. That was like super detailed. Most video game, you know, you just walk up to the door and the door swings open. Maybe you have to hit use, you know, it depends on the game, but yeah. So this is a very common technique. So we walk up, and when the user overlaps us, that means the user has stepped inside of the zone. Then what we want to do is play a sound. And so let's come over here, and we will play sound TV. Again, they're not lined up right. Select cube. Okay. And we'll play, I don't know. Sure, why not? Okay. So we walk over it, it's going to play the clap sound, and all these other things we were doing where we're like spawning emitters and printing strings. Sure, we can do those too. I don't know. Why not? Control C to copy, Control V to paste. Let's get these kind of lined up the way that I like them. Hey, that's a straight line. Look at that. Good job. So that. Okay, that all looks good to me. And then I'm going to hit C when the user walks over this zone. Scare them with an explosion. Not doing any damage. We haven't learned how to do damage yet. But make this scary red color. There we go. So you guys understand? So when the user walks over the box, it's going to play a sound. 2D, so there's no it's not at a location in the world. If we wanted to, we could give it a physical location. So we could do play sound at location. Like this. It's not lined up. And then we could give it a location, and then the explosion will have a physical presence in the world. So if we rotate the camera, you'll hear the explosion from over here. Then while it's playing, if I rotate this way, the explosion will come out over here. When you do play sound 2D, it just comes out of your speakers. There's no stereo effect. There's no attenuation. It just is like UE effects, like when you hit escape in a menu, it goes junk, and it brings up the pause menu and stuff like that. When you play a sound at location, it actually has a presence in the world. And the further it is away, the quieter it is. And maybe you can do attenuation effects. Like if there's a wall in between, you hear only the low filtered, sounds coming out of it and stuff like that. So when I play it, it's going to do play sound 2D. Doesn't matter how far away it is. And now I'm going to walk up to it. And when I overlap it, it's going to play an explosion and have a sound in the world. All right. And we'll trigger every time I enter there. Yep. That's another thing you can trigger. So basically every time somebody walks over it, do something. And this could be something like, hitting a button or, call an elevator, the user walks up and the elevator gets called and the elevator comes down to you. Be as simple or as complex as you want. Okay? One other way of triggering things is called event tick. Now, event tick you want to be cautious with. Event tick, a tick means a frame of the gameplay, basically. So if you have 90 frames a second, this is going to be called 90 times a second. So if I do something like play a sound here, it's going to be playing the sound 90 times a second, and this is probably going to be annoying, maybe is the right way of putting that. Play sound 2D, and we'll play... play an explosion sound every frame of the game. You guys ready? No. I think we're hitting audio. I think we're hitting like the cap of the number of sounds you'd be playing at once very quickly. You heard that reverberating. That was like every frame it's triggering a new explosion sound. Yeah, this is not great. Like you have to be careful with event tick. Event tick has something called delta seconds, which tells you how long it's been since the last frame. This is really useful if you're doing something like damaging the player every second. Because if you damage them every frame, the higher the frame rate, the faster the player dies. This is bad. So what you can do is multiply the damage you're trying to do by delta seconds. So if you're getting 100 frames a second, delta seconds is 1 over 100. And so you multiply the damage you're trying to do by 1 over 100. So the higher the frame rate, the less damage you do per frame. And it multiplies out to 1 damage a second. So if you're doing 2 damage a second, you multiply 2 times delta seconds every frame. And you'll end up having the math work out, so you do 2 damage a second. If you get a frame rate of 10, you'll do 2/10 of the damage per frame. And you have 10 frames, so it does 2 damage. If you have 100 frames a second, you do 2/100 of a point of damage per frame, so it works out to 2 damage per second, because you have 100 frames per second. So delta seconds is very, very useful for things like this. For something like this is just not good. So let me show you a trick. It's one simple trick that doctors hate, and that is using a delay node. So a delay node says, hey, wait a little bit of time. I'm going to hit Q again, because again, it's not lined up right. Good. So delay node, if I put a delay node, the city of Delano, no. If I put a delay node in here, then it will wait for a second, then play the sound. But here's the cool thing. Until this whole thing finishes, it will not do another tick. So the event tick, when it's triggering, it will not trigger another event of the same type while it's still running. And so what this is going to have the effect of doing is reducing my 100 frames a second or 140 frames a second to 1. So it's going to trigger, it's going to wait for a second, then it's going to play an explosion. And so while that thing is delaying, it cannot trigger again. So I've sort of reduced. It's still annoying. It's still annoying. It's still not great. It's still super annoying. Every second we're getting a new explosion. But at least it's not trying to play the explosion 140 times a second now. It's like some tribal beat or something like that. I mean, it's kind of cool, but yeah, it's super annoying. So yeah, be careful with event tick. But if you have to use event tick, then there's tricks like delay, or you can do what's called run once. And then after that, you do a delay. Second. And then after the delay finishes, and it resets, and it can do it again. That way you don't have a second lag on doing something. It's still going to play once per second, but now it triggers immediately instead of waiting a second before it plays. So there's all sorts of like little tricks like that. I am just absolutely going to turn that off because that is super, super annoying. Okay, so usually though for our box triggers, we do this, right? So we got our box trigger, we got an event overlap, and we do stuff. So what kinds of things can you do? You can do things like add health or subtract health, you know, so you can make a health pickup zone. You walk into it, your health goes up by 10. Or you can make lava, that while you're standing in lava, event tick. You take damage every second. You can mess with people's rotation, location, scale. Like sky's the limit. Like really, you know, anything you can imagine. Maybe not everything. You know, there's some things that are still kind of hard to / impossible to do using blueprints, but you know, pretty much most things that students have ever suggested, we can do in blueprints. So we can make like a soccer game, maybe something like that. What do you guys think? That'd be fun. We got like 20 minutes left. You want to make soccer? World Cup just ended, right? Something like that. Spain just won, something like that. Any of you guys soccer players? Yeah. All right. Let's give that a shot. So let's come out to the world and let me impress you all with my super impressive. Maybe we'll just get rid of you. I'm going to turn this area into a soccer zone. So I am going to impress you all with my modeling skills. I may not look like it, but I was a model. So we'll scale this up a little bit here. Create a little soccer zone. And so basically what we want is if a ball, and we can make a ball. How do we make a ball? Sphere. There we go. We got a ball now. Yay. All right. And we want the ball to roll when like people hit it. So we're going to go over to physics here. We're going to simulate physics. And its mass is 100 kilograms. That's kind of high. Let's drop it to like 20 kilograms. And make it a little easier to push. And as far as the water goes on it, we could make it water, actually. It'd be kind of interesting. Water ball. I can work with that for now. So we got our goal here. We're going to duplicate it and slide it this way. Okay, so we got our goals. So now we just need to make an end zone, right? So this ball here I'm also going to mess with. So this ball here, it's a water ball of the ocean. I'm going to turn this guy into a blueprint. Button, again, is right there. I'm going to call this guy my ball BP. And you can see it's this cool little water ball thing here. And that's all I'm going to do with it. I'm going to snap it up here. I'm actually not going to have any code on it, I think. I was thinking that maybe we can make it so that if the ball rolled off, like if we, like here, let me show you what we got right now. So right now, we've got this ball, and we've got physics enabled on it. So if I were to come over here and push it, then it works like a ball, right? And what I want is for us to be able to sort of kick it around and try and score a goal, right? That feels pretty good. The physics on that feels pretty nice to me. Before, the ball was like 100 kilograms, which would have been very hard to move for my mannequin. But now, like, this is responding pretty well, actually. Like, that actually feels like just right, the right thing. You can see, like, the ball can, like, just run away, right? So I'm kind of thinking that maybe we make it check its position. And if it gets too far away from home, we'll teleport it back home. How does that sound to you guys? Put down a little plane here. And this can be little grass field down there. All right. So we got 20 minutes. Okay. So we got our goals set up. We need a box trigger that will trigger when the ball rolls over it. And then we need to make like some sort of scoring system or something. I don't know. Do we? And then we need some ability for the ball to like reset itself. So how do we want to do this? Well, why don't we, let's start with the ball, I guess. So, because it's going to be really annoying if the ball just like rolls off the field and goes down the hill, like we're not going to get it back. So let's go back into my ball. And maybe it's time to learn variables, right? So when the game begins, I'm going to write down on a piece of paper where my starting location is. So when the world begins, I'm going to get actor location here. And this location is going to be whatever spot it's dropped at in the world. And I want to save this as a variable. So what I'm going to do is I'm going to right-click on this pin. This is something new. Pay attention to this. I'm going to right-click on the pin, and I'm going to choose Promote to Variable. And what Promote to Variable will do is it will make a variable of the type of that pin, the orange color, which is holding XYZ coordinates for the world. And it's going to make a variable, and it's going to give it a name. And all I have to do is just come over here and hook that up there and get annoyed at it not being straight and hit Q. And then I have to come over to here. So over here, you can see all the variables we have on our blueprint. Currently, this is the only one. So if you want to rename it, you can right-click on it and choose Rename, or you can hit F2 as you see there. Or one fun trick that I like is you click on it, then move the mouse slightly, and then that will bring up the rename. This works in Windows, by the way. So you have an icon on your desktop, click on it, then slightly move the mouse, and it'll turn into the rename thing. So I'm going to call this one starting location, like this. And yeah. So basically, I'm going to save the starting location. And then what I can do is every frame, which again is not great, but it's not the end of the world. Maybe I'll add a delay to it or something. But what I can do is I can say every tick if I'm more than, I don't know, 20 meters away from the starting location, teleport back to the starting location. So you're going to have to learn how to do if statements too. Okay. So what I'm going to do is every tick, I am going to get my location, get actor location. So basically every frame, I'm going to be like, where am I? Where am I? Where am I? And, maybe I'll put that delay note on there. Just so I'm not doing this like 100 times a second. I'll do it, sure, five times a second. That's good enough. Nobody's going to notice if it's 0.21 milliseconds or 0.21 seconds or 0.20 seconds. Like nobody cares. So 5 times a second, I'm going to get my location, and I'm going to see if the distance between my starting location and my current location. Watch this. If I want to get my saved starting location, I drag this out here. Get starting location. Okay. So now I've got my starting location, I've got my current location, and I want to know what is the distance between them. So if you guys had to guess, what should I search for to get the distance between two different points in space? Just take a wild guess. I've got a point here, and I got a point here, and I want to know how far apart they are. What do you think? If you just had to wildly speculate, what do you guys think the name of the function is to tell the distance between two things? Ruler? Let's find out. It is not ruler. Is it distance? It is. Okay. And now you might notice that there's a lot of different distance functions here, right? There's a lot of them. Distance vector, which is probably the right one. Get point distance to line, distance 2D. What is all this stuff, right? Let me show you a trick. If you drag off of a colored pen rather than just searching, if you right click and just search for distance, it's going to turn up every single distance function for every different type of thing. If you drag off a colored pen like this, left click drag off a colored pen and search for distance, then you get a lot less options. And so I'm just going to pick distance vector. Doesn't matter which one is vector 1 and vector 2. But what this is going to tell me is how far we have traveled from the beginning. Okay? So we started here, and every fifth of a second, it is going to be like, how far away am I? How far away am I? How far away am I? And so one of the first things I always do when I'm coding something like this is I just print the number, right? Before I come up with like a number like, oh, you should teleport back when you're 10 meters away, I like to actually just print, how far away am I? How far away am I? How far? And I like look at it when I'm playing. I'm like, okay, here seems like a good place where it should teleport back. Then I put that number in. Okay. And so what I can do is print string. You will see me doing this over and over again this semester. Is before I do anything interesting, I am going to just print things to the screen. And so print string takes a string by default, but if you were to drag the distance onto the string, it'll actually convert it for you. So this will print the distance we are away. Does that compile? Okay. Now if I run this, you will see 5 times a second, it will print how far away the ball is from the origin. Right now it's 0, or not origin, but how far away it is from its starting location. Watch, if I come up here and I nudge it a little bit, you will see it is now 40, 50, 60 away. So a lot of students get confused what these units are and think that they're in meters. These are not meters. These are centimeters. Okay? So the base unit of measure in Unreal Engine is a centimeter. If I kick this over here, through the goal, it is now 10 meters away. So should I reset at 10 meters? What do you guys think? Oh, where did it go? Oh, dang. Down here. I can't see anymore. But it's like 22 meters away now. So let's run that again, maybe. So what do you guys think? How far away should it go before we reset the location? Just give me a number. How many meters? 10 meters is about 3 meters past the goal. 20? Yeah, 20 seems somewhere in there. Sounds about right to me. Okay. So I'm going to make a new variable. So you can make variables by right-click promoting something. Another way you can do it is by coming over to the variables tab over here and clicking on the plus. And I'm going to make a new variable called max distance. And if you click on the little type option here, I'm going to choose to make it a float. Know that it's the same green color as this. A float is a single number, not a vector. A vector is 3 numbers here. But a float is a float and a floating point number. And I'm going to give it a name of max distance. The description is how far away the ball can travel before resetting. Yep. And if I want to set a default value for this, which I do, I compile it, I save it, and then you can see the default value is 0. I want it to be 2,000. Not 20. Not 20 meters. 2,000. 2,000 is 20 meters. Centimeters. Okay. And then what I'm going to do is I'm going to check. I'm going to do a comparison. I'm going to say, hey, is the distance the ball is away currently greater than or equal to? I just typed greater than or equal to. Not. I didn't type greater than. Oh, well, I guess that'll work. I never do that though. You just type the greater than sign and greater than equal sign, and then click greater or equal to, and then watch. I can drag the variable out. Watch this. Now, normally you can drag the variable out and choose to get it or set it. This gets the value, and I could hook it up. It'd be fine. It's a perfectly acceptable way. But watch this. If I drag the variable on top of the pen, it'll automatically make it a get. And I don't have to choose. I'm just going to line these things up, make it look pretty, and move this down a little bit over here. Okay, so what I'm going to say is if this returns true or false. So is it true that the ball is more than 20 meters away? And so this is the third learning point for today, a branch. So a branch says if something is true. How did I do that? I right-clicked and typed branch at the speed of light. And no. If you hold down B and click, you get a branch. Okay. So a branch says if something is true, if this is true, notice I'm hooking it up here. If something is true, do one thing. And if it's false, do another thing. And as always, when I'm coding these things, I start off by just printing a string. So I come up here and say print string. And I'm going to print ball is more than 2,000 centimeters away. And copy paste. And if it's false, that means ball is near its home. Don't you want to go into your home? That's your home. Why don't you go into your home? It's Happy Gilmore. All right, so if I run this 5 times a second now, it's printing ball is near its home. Ball is near its home, right? If I come up and I give it a nice kick, boom. Then once it travels 20 meters away, you'll see ball is now, you can see it off in the foliage in the distance. You can see it says ball is now more than 20 meters away. This guy sucks. Yeah, Bob. Bob Barker. That's such a great, stupid movie, but a great movie. Okay, so this is how I start off with it. And I just look at it. Like I kick the ball around and I'll be like, all right, does that seem about right? You know, is this about the place that we should reset it back to start? Yes, no, I don't know. You know, maybe I'll pull this in a little bit. It seemed like it kind of got far before it resets. I'm maybe going to turn this down to 15 meters instead. And so if the ball is within 15 meters, I'm not going to do anything. So I can just leave this open. If you leave it open, it does nothing. So if I'm within 15 meters, do nothing. But if I'm more than 15 meters away, I'm pulling it in, like I said, to 15 meters from 20. Then I'm going to set its location. So set actor location is another thing you can do. Basically, anything that you can set here in the details panel, the location, the rotation, the scale, all of these things. If I wanted to make it bigger, I could scale it up. Every time it teleported back, it gets bigger and bigger every time. That'd be kind of funny, honestly. Maybe we'll do that next. But we'll just say when it gets more than 15 meters away, then reset. And so what location are we going to set it to? The starting location. So I'm just going to drag starting location over here. And this is going to basically teleport. So we are basically going to teleport the ball to the starting location. And if everything works right, then we'll be in a good place for Thursday to do scoring and things like that. So we got a little delay here. All right. Hop over here. And if I kick this, you can see as long as I'm within 15 meters, everything looks good. Should be about 10 meters away now. And then boom. And then it's back over here again. Now it's keeping its velocity, so probably we should also set velocity on it. Set all physics, linear velocity, static mesh component, sure. So set the velocity to 0, because it seems weird for it to keep rolling, you know. And then what was the other thing we're gonna do? Oh yeah, we're gonna scale it up. So we will set scale on it. Set factor scale 3D. And we will make it, I guess we could track how many times it teleported, but for now we're just going to make the ball twice as big. So the first time it teleports back, it's just going to get twice as big, and it'll stay that way forever. Okay. So come over here. And the ball is silently judging us, how far away we are. And we're going to kick it through here. And there it is. Oh, it didn't change the velocity. And yeah, so we can make a variable that like tracked how many times it teleported and scale it up based on that. So this is actually kind of funny. All right, why did the velocity? That's right. That's going to make a difference. Yeah, it's keeping its velocity. Physics is one of those annoying things to work with. Let's see here. Set all physics linear velocity, maybe. There's a lot of options for this, and I don't mess with it enough to remember. I'll have to play with it some more. But yeah, basically we should be stopping it, right? In the meantime, why don't we just make it grow every time? So basically every time we teleport, let's increment a counter, so we'll make a new variable here. This will be a good learning experience. So this will be called times teleported. Times teleported will be an integer, and integer is a whole number. Compile, save, times teleported defaults to 0. So every time we teleport, we are going to do times teleported. Let's see if we can do a plus plus on this. Let's see. And then the watch this. So this guy's going to go from 0 to 1. Actually, we should start with 1, I guess. And it'll go up to 2. So watch this. If I have a single integer here, if I drag it, it should replicate that new number out to all of them. do that. I can also split the vector, which I'll show you how to do in a second. Come up here and kick it. Then it goes up to size 2. Then it becomes size 3, size 4, size 5, size 6, size 7, size 8, size 9. It just gets bigger and bigger every time until it gets too big to fit between the goalposts. It still has a mass of 20 though, so I can header it with my head. There you go, a little World Cup soccer action there. There we go. It's even bigger now. This water ball. Header, header, header. It's like playing Katamari or something like that. So what's going on here is I've made a variable named times teleported. I start off at 1, so it'll increment to 2. So every time I teleport, I use the plus plus, that means increment. That'll change from 1 to 2, and then I set the scale to be that. Now, there's another way that I could have done this, which was by right-click and choosing split. And then that would allow me to change the X scale, the Y scale, and the Z scale separately. So, for example, I could hardcode XY at 1, but have the Z scale, the height of it, increase, which is going to look really terrible and probably hilarious. So it's going to grow taller and taller, but not wider and wider. So it's going to become a very ineffective ball, I think, very quickly. But it should be hilarious. So let's see how this looks. I amuse myself sometimes. Like some eldritch horror now instead of a soccer ball. And it just keeps getting taller and taller every time. Yeah. What do you guys think? It's kind of hideous. I don't know. What do you think? Kiana, what do you think? It just keeps going too, getting taller and taller every time. Well, okay. So your homework is going to be making a basic goal kind of thing, making it playing a sound, doing a particle effect on the overlap, what we talked about earlier. This kind of stuff we will continue on Thursday, where we'll make a simple interactive soccer-like game, and then move on to more complicated programming later in the semester. So that's it for today. Thanks for coming out, you guys. I'm going to put this ball back to the way it was before, because this is honestly kind of disturbing. So, see you guys next time. Peace.